Where did I hear that?
What is that?
No,
What is that?
it's from, I don't know if it's from Mr. Bonds or some Leon Schuster movie. I'm pretty sure of that. I just can't remember which one. Maybe I think it's there's a Zulu on my stoop or something. Yeah,
Yeah.
maybe.
You remember. I think I watched it
Yeah,
years ago.
yeah.
Years.
But that sounds familiar, right? Yeah, Marsha, Bella, something.
Yeah,
From
it
this,
does.
yeah, that's from that black guy. Uh, but
The
it's
short
fine.
one.
Let's see. No, no, man. The
The fat.
I don't know. I can't describe it. Not the fat one. The one with the afro. I think the guy.
You
I think
remember
it's
what
the same. I think it's the same guy that acted on. Is it Rocky? Yeah, no, I'm lying now. Never mind. Let's just forget
uh,
about it.
how
Let's just,
I don't even know that.
yeah, yeah. That just escalated very quickly. So we need to prove similarity here.
Yeah.
Now the thing with proving similarity is, yesterday, was it yesterday? No. It was the day before yesterday, man. I was doing the Northwest paper 2
Right.
paper, the full one. And then I always say that these always match, right? Like how L goes with K, K goes with S, N goes with M. It's always like a good hint. But then in that
Mm.
Northwest paper, yeah, those examiners were evil, bruh. They mixed up everything. This was not matching with this. This was not your. I was just like, wow, that's just like some plain
So what
evilness
do you
right there.
think if there's such a scenario?
Well, in such a scenario,
Because
it just
if you
means you're on
given,
your
you'd
own,
expect that, ha ha, just like that.
No, it's just like one of those things where if they do it like this, where things match, right, they're just being nice. Like they don't have
Yeah.
to. But remember, if you're gonna prove that this L is equal to this K, you have to have a reason. The only thing with that Northwest paper is it just didn't make sense that the letter here was going with the letter there because they clearly were not equal.
Yeah.
But
Yeah.
anyways, for example, for this question, there's LKN. So there's LKN, meaning we're dealing with this triangle here. Now in this triangle, I don't know, the thing is, you see, whatever angles we have proven to be equal and all that, they can help us here some way, somehow. So we're dealing with K, we're going LKN, and the other one we're dealing with is KSM. So KSM, you can see it's quite a weird looking triangle. It's much smaller than that other one, but it doesn't matter. It is what it is. So what you want to do is you want to keep in mind that some of the things we've proven here, let's maybe see what we've proven to be equal. Well, in this previous sketch, there's nothing in this small triangle here that we have gotten an angle for, and you can see it nicely. Like none of these angles here, we don't have anything to say it's equal to something else. But then, as we said already, with most papers, like a good 90%, in my opinion, the letters of how they label this will always match what you may call the ones that are equal to each other, you see. And I'm looking into myself, what just happened here? Like, this thing, now we have to like take it up and match, and but so much work. I know, man. Hey, this will just have to work. We'll just have to make it work. So what I normally say is, you see the L here, right? Let's see, angle L here for this triangle is this one. So this angle here, we want to say that it is equal to this one. If we can find an easy reason why, we might as well do it. But if you cannot find an easy reason to say that this is equal to this, you might as well just forget about it. Try other ones that are usually easier. The next one, let's see the K in the one triangle, which is like this full one here, equal to the S in the other one, which is like this full one there. Whew. Yeah, it doesn't look pretty. It doesn't look pretty at all. And then the last angles, the last ones that are going to be equal is going to be the N in this triangle and the M in the other triangle, which is like here. So at least the N and the M, these ones are a bit easier, or it looks like this is the first one that we can actually prove to be equal without like popping our brains, because these are both subtended by the same line, or rather we have proven that this is a cyclic quad. So automatically we can see that these are going to be angles in the same segment. Because if you look nicely, right, there's N here. N is going to K, N also goes to L. Here there's M, right? M is going to K, and then M also goes to L. You see it?
Yeah.
Yeah. So that's the first thing we can say is equal. N3 is equal to M3. The reason is angles in the same segment. Noise. Okay, it's a 5-mark question though, so we know it's not pulling any punches. It's like throwing hands, like hardcore. So we kind of do need to be creative, I guess, because if we're going to prove that this angle is equal to that one, or the orange one is equal to this whole one there.
Can I just pause you?
Yeah.
I see the drawing that the sketch that you did here on the side, KNLM, but long. I was just about to ask why, because I can see that N, I think that's a N3 is equal to M2. What's this? The
M3.
thing that you, yeah.
3 here, 3 there.
Oh, I was still looking at NKMS.
MKM. Well, whichever way, right? If you can just look at where point M is, right? The line going to K and the line going to L. You can see it, right? There's a line going to K and there's a line going to M. I mean, there's a line going to L. For N, the same thing is happening. There's a specific line going straight to L. There's another one going to K as well. Yeah. So because this, we're proving it to be a cyclic quadrilateral, that's how we're able to say these are angles in the same segment. Now, with our next pair of angles that we're going to prove, yeah?
So we're now looking at MNKL. That's the thing that we're looking at.
MNKL. Are you still referring to the first question we just looked at?
No, I'm talking about what we're trying to work out now, because I think I'm looking at the wrong
okay
diagram.
Okay, so what we're trying to work,
right?
Go on. What we're trying to work out is that this angle here is equal to that one, or the purple one is equal to the purple one. The purple ones, they seem a bit crazy. These ones, they seem a bit easier. The reason is, all we need to do is, remember, if you're going to prove that two angles are equal to each other, just think of what we did in the beginning here. We didn't just prove that this and this were directly equal to each other. We couldn't in the beginning because we firstly did not know that this was a cyclic quad anyways. What we did was we proved that these were equal and we proved that these were equal. And then that's how we're able to say that they're equal to each other. Here, we're going to do exactly the same thing. We want to find something that is equal to S2. Now, can you find any angle here that is also equal to S2?
That K3.
K3. Well, no, we're trying to prove, no, not K3. I think you mean the whole thing. This is equal to this, yes. That's what we're trying to prove based on what we're trying to prove here in terms of us proving similarity. But what I'm saying is, looking at S2 alone, which other angle do you see in the sketch, right, that is also equal to S2?
Yeah.
Like, look at where S2 is. There's a parallel line there as well. Like that should not be something we forget. There's a parallel line there and a parallel line there, and there's S2 here. So what do you see? Yeah, like focus on the parallel lines.
So is it possible for S2 to be equal to M1?
Not possible. It is equal to M1 because those are corresponding angles. So it's not a matter of is it possible, it's a matter of, oh yeah, they are equal because those are corresponding angles, you see. So we have found something equal to S2, right? So here we can say S2 is equal to M1. The reason is corresponding angles. Now, remember these questions, right? This is one thing you can do for yourself to like hack questions. Like the thing with questions is sometimes we're always trying to think of our own ways of answering these questions. But the easiest thing to do is any question you answer, right? Always focus on what you would have previously worked out. Like here, we see here we worked out that we have a cyclic quad somewhere. And here this helped us to answer this. Now this is going to help us to answer this, because now look, because we now know this is a cyclic quad, that's something you should not just forget just because it's in the past. No, if this is a cyclic quad, automatically this is now useful to us. This angle M1 here, we said S2 is equal to M1, right? And we're trying to prove that S2 is equal to this one. And we said all we should do is find an angle that both of these are equal to. Now this is already a guinea pig because you have already shown that S2 is equal to M1. So your job should be just for you to show that, okay, wait, this is also equal to M1. Now the one way we can see they are equal here is because this is a cyclic quadrilateral and this is an exterior angle. Even if you check in the previous question here, you see you have a cyclic quadrilateral here. M1, we know it's equal to that angle over there. Or rather, if we focus on this image, we have K here, we have N here, we have M here, and then we have L over there, you see, and then we have this line over there like that. We have an exterior angle here, it's M1. You see, M1 is equal to that angle up there that we're trying to show is equal to S2. So that's what we can say. This angle here, NKL, let's write it down. NKL is also equal to M1. The reason is exterior angle of a cyclic quad. Exterior angle of cyclic quad, like this. You see, so we've proven that they're both equal to like M1. So we can say they're equal to each other. Therefore, S2 is equal to NKL. The reason is they are both equal to M1. You see, that's more of a conclusion. So because we have shown that two pairs of angles are equal in our triangles, you see, we have shown that if you look at the question here, we have shown that, let me just get maybe like a red here. We have shown that the what you call, in our two triangles, right? We showed that the N here is equal to the M. So that dealt with this, the N here is equal to the M, right? And then here we're showing that the angle K is equal to the S, you see. So here where the K is, where the K is there, it's equal to this S in the other one. So you see two pairs of angles were proven to be equal. So the last one, which is this L and this K, we can say they are equal to each other because of interior angles of a triangle. You see, this is like K2, this is L1. So here we can then say L1 is equal to K2. The reason is interior angles of a triangle. You see, or you can say here sum of interior angles of a triangle. It doesn't matter what you write, it's all fine. But let me just put it like this one: sum of interior angles of a triangle, like that. And then you've proven that all three angles are equal. So then you can then say here, therefore, triangle LKN is similar to triangle KSM. I should remove this thing here. There you go. The reason for writing this would be angle, angle, angle. You've proven that three angles are all equal to each other, which is the only way to prove similarity anyways. So you are good to go, unless you had used ratios, but that's like unnecessary. So yeah, does that make sense?
Yes, it does.
Fantastic, fantastic.